This is the AC30 TB TBX series, an amp which in stock form is very noisy and hummy. And if you own one of these or you've played one of these, you know what I'm talking about. The hum is caused by three things. First of all, there are ground loop errors in the design. Second of all, the way the heaters were implemented was not very good. Third of all, the input signal for the top boost and normal channels is routed right past some really noisy stuff. So let's talk about the ground loops first. This board, like all the TBX boards, has one great big U-shaped ground trace that goes all the way around. So it goes from the input jacks to here, and goes to that point where that green wire goes to the chassis, and it goes from the output here, and grabs all the filter cap negatives, and then goes through a very small trace on the board to the same point. But the earliest versions, which only have the one green wire, also have a small trace tying the shell, the case, of the top boost brilliant volume pot to that ground trace. So when this board is in place and this pot shell is in contact with the chassis, there are two paths to ground, both here and here. That creates a ground loop. At some point, the engineers at Korg realized that, and they issued a service bulletin showing to cut that trace and to add a second green wire from the output to cathode to ground. So at that point, they thought they had solved this ground loop here. They introduced another one, because while this trace went here with a green wire to ground, and this trace went here with a green wire to ground, they forgot that those two traces were tied by a small trace in the middle. If they had cut that trace or eliminated that trace, they would have eliminated that ground loop. They did not. So if you see an amp which has one single ground wire, one green ground wire, you know it probably still has the ground loop on the top boost volume pot. If you see an amp which has two green wires, that's probably fixed, but there's still a trace from here to here underneath the board. So the fix for that is to have your tech cut that trace. Please don't do this yourself unless you're 1000% sure what you're doing. I don't want people watching my videos on YouTube and then modifying their PCB amps, because it takes a lot of skill to work on PCBs without doing any damage. That's the quick and dirty way to eliminate the biggest ground loop in these amps, so that all this stuff has a path to ground through the green wire. All this stuff has a separate path to ground through its own green wire, and they only join here. What I've done on this amp is I've divided the ground into three zones. So I have all the input and preamp stuff on one ground trace, which is not going to chassis here. And then I've got all the output stuff and the filter cap negatives up to the screen resistor, the screen node ground, and the 220Ks for the bias reference. That's a separate ground node. And then I have the reservoir cap, the reservoir node going to here. And the only other thing going here that's important is the HT center tap. Also have the pilot light going there, but that's not important. So over here by the power transformer, the noisy grounds in the amp, the CT for the HT supply, and the reservoir cap ground, those are going to ground here. And I have two new wires here. One for all the input stuff and the preamp stuff, and one for every other filter cap and the output. And those are going to chassis over here, along with the output transformer negative. This is the most optimal way to do this, I have found. It also makes the input jacks reject RFI quite a bit, because instead of going about 2 feet to chassis ground, they go about 6 to 8 inches, depending on the length of your wire. You want to leave it long enough that you can flip the board up for service, but not any longer than what you actually have to have for future service. So that's how you get rid of the ground loops. The next issue is there's a lot of hum and buzz injected into the input signal going to the top boost and normal channel, because they have these little traces running on the board underneath all these other components to get to here. And what are all these other components? Well, they're parts of the oscillators used in the tremolo and vibrato circuit. These are very noisy parts of the signal. There's a lot of voltage spikes and stuff. I'm not going to get too technical on that. But this is just a very noisy place to run the input signals. So what I do is I remove the grid stoppers here, and I cut the traces right near pins 2 and 7 on this tube. You can see some cuts with some clear acrylic so the board doesn't absorb moisture. And then I run shielded wire beneath the board with new grid stoppers going from here to here. And the reason I do it on the bottom of the board is not to hide my work, though it is very neat, but to keep those input wires farther from the heater wires, which they're roughly in parallel with. If I had done the shielded wire up top, I'm in parallel with all those heaters. I'm still in parallel with them, but you know, it's almost 3 inches away as opposed to being within half an inch of each other. It makes a huge difference in the background noise and hiss and hum and buzz. And then we get to the heaters. This is well known. They use red and black wires for all the heaters from the preamp, and they're usually very loosely twisted. And you get very little rejection out of that. What I've done is I've replaced them with much more tightly twisted wire, and that really helps a lot, because with the stock red and black, people find a certain position that's kind of okay, and then they might put some glue in there, or they'll get some zip ties, and it's not necessary once the wire is twisted right. The other thing I do is I don't reference the center tap on the heater from the power transformer to ground, especially not this noisy ground here. I lift that and I install artificial center taps on the heaters, referencing the output cathode, which is at about 10 volts. Now, 50 volts is the theoretical ideal DC lift, but 10 is still better than ground. And the combination of doing new wires here and the artificial center tap here gives a huge reduction in noise. And then there's the reliability error on this amp. And the reliability error is that this trace right here is a heater trace feeding the output tubes. And what's right across that heater trace, in stock form, you've got the screen grid resistors and the grid stopper resistors, and they're right up against that trace. So the only thing between this high voltage resistor, which does sometimes fail, and this grid resistor, which if it fails or has a short, you're going to lose output tubes and or output transformer, is the masking on the PCB. If they had done these resistors elevated off the board, like you see I have the screen grid resistors, they've been less of an issue. But you have this heater run right through there with very little insulation, just the solder mask. They fail. So I disconnect these traces. So this trace and this trace are no longer tied to the heater over here. I've cut them and I've sealed them. So nothing's on these traces. Nothing to short out. So I have the grid stoppers up against the board here. And then I have the screen grid resistors replaced with some 3 watts, which are up off the board by, a little over 1/4 of an inch for some airflow. So these are going to run cooler, they're less likely to ever fail, and if they should fail, they're not going to burn the board. And even if I hadn't lifted them, if they did burn the board, they would no longer be shorting to the heater supply. So this is all stuff you should have a tech do. Maybe I shouldn't give out all this information for free, but the reality is I cannot fix every amp in the world. Geography and money prevents that. So I'd like, if you own an AC30 TB or TBX, to take this to a good tech, show them this video, and they'll say, yeah, okay, that makes sense, we can do that. And it's not terribly expensive. And the thing that gets me is that this is the kind of stuff that should never have been released to market. Never been released to market. This is engineering 101 mistakes. I don't understand how certain companies keep getting away with terrible mistakes, like the Marshall GSLs, where the entire board becomes conductive. That should have been a recall, but that's for another subject entirely. Oh, on one other note on this amp, I had to replace the power transformer because the stock power transformer was really becoming defective. The laminations inside it were vibrating. It was physically vibrating. You could hear it buzzing as soon as the amp was turned on, even if it was in standby. And once the amp came out of standby, that buzz was being injected into the speakers. I think it was making a radiant field that the phase inverter inputs were picking up on just because of proximity. But I changed that out for mercury magnetics, and all the noise went away. So that's nice. So if you do all this work and you still have about 120 hertz buzz in the background, check the power transformer. Just put your ear up against it on the other side, not the side that'll zap you. Thanks. But hope this helps someone.